Hi there, folks. I hope you're doing well and excited about learning about another design pattern. In this video, I'm going to teach you about a very popular design pattern known as the factory method. And it is very specific, meaning it's a method that we're going to be implementing, or the factory function. And let's go ahead and figure out what this is from the definition, and we'll dive in further. So, what is the factory method? The factory method pattern provides a generalized way to create instances of an object and can be a great way to hide implementation details for a derived class. So, what does this have to deal with here first and foremost? The first thing that we have to keep in mind is, well, what category of pattern this is. And this is another creational design pattern. And in previous videos in my playlist, which you can check out, we have learned about creational design patterns such as the singleton. It's a way to abstract or make safer a way for us to create objects. And the idea of this sort of generalized way to create instances of an object so that we're hiding implementation details for the derived class is by, well, just creating a method or a function. So what do we want to avoid when we're using the factory method, or what problem is this trying to solve? Well, let's just say that I have some type here, like a game object, because we can sort of think in games. And I'm going to create this as a pointer here because I want to, well, determine at runtime what the type is of this object. So maybe I'll just explicitly say this is a new object 1, whatever that type happens to be. But this is exactly what we want to avoid. We don't want clients of our interface, or perhaps implementers who are working on our code, to have to make this decision and be allocating our objects. Instead, what we want is some function here where we can provide an input. So here's our factory method or factory function, and get the correct output. So it's as simple as that. And let's go ahead and dive into the implementation so we can figure out what we're going to do. Now, a key part of this pattern and what makes it work is for us to be able to use what's known as inheritance, and in particular, polymorphism. So inheritance-based polymorphism. So that is, I want to create some interface. I'm just going to call iGame object and derive classes from this. So for example, we'll have a plane class, and maybe we'll have a boat class, and we could derive as many other ones as we'd like. So I'll just make a note here that we're going to be taking advantage of inheritance-based polymorphism. And you've probably seen this idea of polymorphism in a couple of different contexts, like when you're creating objects, or function-based polymorphism, but again, it's important. So that's what this concept here is describing. All right, so let's go ahead and get into our implementation, and we can play around here. So I'm going to go ahead and make this font a little bit bigger, and let's go ahead and create our factory function. Okay, so I'm going to go ahead and just open up a main here. And what you'll see here is that I've already described a game object here. And you'll notice that I've named this with an I in my class, and that's sort of a convention I use, that this is going to be some interface. And I've got a virtual destructor here, since we are going to derive from this class, and 2 virtual void functions here that are set equal to 0. These are purely virtual functions, which means any class that we derive from must, again, implement these 2 member functions. Okay, so that's important to keep in mind, and just a little bit of C++ for you there. Okay, so what do we need to do? Well, we need to derive our objects. So I'm just going to go ahead and create a plane class here, as described from our diagram on the right side. And that's going to inherit from iGame object. And I'm going to go ahead and do the same thing for boat here. iGame object, and here we are. Now we're going to need some sort of constructor here for our plane, and I'm just going to leave it empty. And we need to also implement the update function and the render function as well. And I'm going to go ahead and copy this and paste this in here for our boat, carefully remembering to rename the constructor and avoid some copy and paste error. So here's our code. Now let's just go ahead and see if we've made any compilation errors and go ahead and just see if we can instantiate planes and boats on their own. I'm going to use C++17. While this code at this point doesn't use any particular features important for C++17, I like to be using different stuff. Okay, so this runs and executes, and we have sort of the shell of our program here. Again, what we've created is this hierarchy. Now, again, remember the purpose of the factory method is for us to avoid having to make decisions about which object that we're creating in our code. In fact, we want to be going through the iGame interface for each of our objects. So let's go ahead and create a function to do this. So what are we going to be returning from our function? Well, some sort of iGame object. And we're going to be returning a pointer in this case so that at runtime, I can determine what that actual type is. So let's go ahead and give this factory a name. I'm going to call this the make game object factory. And stylistically, I do like to put factory in the title because it becomes very easy to grep or search for in your code base. The factory pattern is used in a lot of code bases, and I've been able to find it by just grepping for the term factory. Okay, so what's the argument going to be? Well, for now, I'm just going to make this a string and maybe the type as the parameter here. And we'll see how we might want to refactor this, so hang with me in the video. But I just want to start off with something simple here. So we need to return some sort of type here. Well, let's go ahead and figure out what type we can return, and that's just going to be all the things that are derived from iGameObject, which are planes or boats. So if the type is equal to a plane, then we will return a new plane object. Else if the type is equal to a boat, then we should return a new boat object here. Okay, and I'm going to go ahead and leave this here, and let's go ahead and give this a run and see what happens here. So now, instead of returning a plane or boat explicitly, we can decide at runtime what type of object that we want to create. And this can help make our applications more data-driven and flexible in this way. So now I'm just going to have an iGame object, call it my object, and run through our factory here. And I'll go ahead and move this to the side and determine that we want, say, a plane in this example. So does it compile? Not quite here because we are missing our string library. So let me go ahead and add that right here at the start of our program. That is one error. Let me recompile, and then we'll check the other error. No other errors at this point. Okay, so there we go. Now, we are getting a warning about our control reaching end of a non-void function here, so we might have to figure out what type of object to create here. But I'll get to that in a moment. Now, if I run this program, there are some things that I need to think about, like where is the ownership of this object? Well, it's been allocated within this function, so I should probably also delete this object before the end of our program. So my object here. If I recompile, we still get our warning, and this runs, no problem. It works perfectly fine. And I can, let's go ahead and just do this 2 different times so we can see our 2 objects created. And then I'm going to step through this in GDB just so that you can see the types of the objects here. So compiles. And let's go ahead and run this with GDB. I'm going to use the TUI mode just so you can see the sort of step-by-step. And let's go ahead and start our program, move to the next line, the next line, and the next line. Now, before we get to deleting our object, let's inspect and see, did we actually get a plane back here? And you could try something like what is, if you're familiar with that in GDB, and it says iGameObject. Well, that is what object is. Or you could try printing out my object here as well, and it's still a myGameObject. But for us to really see, we want to be able to look at the vtable of my object. And if we do that, we see that it's been set up to be a plane. And let's just check our second object as well. And that's been set up to be a boat. Okay, So this is a way that we're inspecting in GDB. If you don't want to use GDB or are using a different debugger, another way that you could handle this easily is just to actually come up in these functions and implement in the constructor boat constructed or something appropriate, right? And you would also want to implement the destructor and so on. Okay, so we know this is working, but there's still a few problems, and this is where I want to help you improve on the factory method. If you've watched this far, you have completed your first factory. It's as simple as this as far as the pattern goes. But again, we have some problems here. So, for example, we do need to return some sort of type here. For example, maybe the null pointer here just to get rid of our warning. So let's go ahead and make sure that we do that. No more warnings in our program. However, what happens if a user messes up using our interface? For example, maybe they pass in capital boat and capital plane here, and we run this program, and you can take a moment to pause the video and predict what's going to happen. And in 3, 2, 1, well, what happens here? Did our objects actually get allocated? Do we even know? And this is where things get tricky, because it looks like my runtime, if I'm deleting a null pointer, there's no problem. But what if I omitted this null pointer type and nothing got allocated? So nothing was returned from this function. And it's going to give us a warning here. Then I get a segmentation fault. So in either world, I'm either getting a warning and not returning a type because I don't have a default case, or I am perhaps not getting an object and my system isn't catching it. Now, some of your systems on delete of a null pointer might report back to you, or you would inspect this and find an error. But either way, still a little bit dangerous, and we can improve this code. So let me go ahead and try to improve this. And instead of relying on string, because I could have any amount of types and edge cases, like handling an empty string or a string that's really large, or maybe it's just doing a slow comparison, let's use some C++ features here, like creating enum classes for our object type. And I'm just going to create 2 types here, because those are the only 2 that we're allowed to instantiate in our factory. So I'm just going to call these object type, and you might want to name this game object type or factory or something appropriate, but this is what we have here. Okay, so now I'll have the object type that must be passed in here, and I'm just going to call that type here is probably a reasonable name here. And now we'll check against object type and planes, and then again object type and boats here. And we're not comparing against a string, but just our type that was passed in and our type that was passed in. Okay, so I should be able to recompile this. And now I just need to update the actual types passed in when we create our objects. And you'll already notice the compiler helped us catch an error here that we don't have a type because we can't pass that in as a string. So instead, we're relying a little bit more on the type system to catch these errors. So for this one, we'll do a plane. And for this one, for our object type, we will do a boat. And let me make this a little bit bigger so you can see everything on the screen. And voila. Okay, so let me save, recompile. And I'll just fix one compilation error here. This should be uppercase boat. And there we go. Okay, and if I run this, no problems here. So already this is protecting us in a way of the types that we can instantiate or return to my object. So I really like that refactoring. Now, there is another refactoring that we can make as well. And it has to deal with our sort of implementation or whatever our API we might want to design. And returning raw pointers, some folks may not like. So let's go ahead and give ourselves the power of smart pointers by including the memory library. And instead of returning a raw pointer, let's return a standard shared pointer, and it's going to be of type iGame object here. So again, we're trying to avoid some of these direct calls to new in our code as well as our interface. and we'll just return a standard make shared. And this is going to be a plane here. And let's go ahead and do this as well. So standard, make shared, and then now we are using pointers here. Actually, I'll leave that there. Standard, shared pointer, and this is an iGame object, and this is the same pointer, iGame object, and there we go. Now we'll get a warning immediately on this delete, or an error, because this isn't implemented. Right, that's deleted as part of shared pointer, so we can safely get rid of these deletes here. Okay, and now when I compile, oops, I've got one extra keyword here. Now we should be okay, and no problems here. So I can actually run this program, no segmentation faults, and now our memory is automatically cleaned up when this goes out of scope. So let's go ahead and prove that. You can use a memory checking tool like a valgrind, leaks if you're on Mac, or an equivalent tool in Visual Studio. So if I run the program here, you'll see that there are no blocks remaining in this program that have been allocated, or 3 allocations have been freed here. The 2 here, and then whatever else has been done in the program. So I like this because now we have a factory that creates objects. We don't have to worry about their lifetime, although that is something that you may want to think about, whether this should even be shared pointer or perhaps even unique pointer, depending on the context. If this is a game and you might want to share or have many sort of objects pointing to these other objects in a game, that might make sense. Or you can make these unique pointer by default and then convert them to shared later. That's okay. But I don't want you to get lost in the details. I just want you to focus on, for now, this is a modern factory method in C++ that you can use. We've made it safer by using enum classes here, so you can only instantiate the correct types or types that are supported, and you have each of the conditions here for returning that smart pointer. So let me go ahead and make this just a little bit smaller so folks can see everything on the screen at once as you evaluate this pattern here. So there it is, all on one screen. And here is a refresher of our pattern itself here, just so you can see. So again, we used inheritance-based polymorphism. We have our interface here, 2 different derived classes for that interface in enum, and then of course our factory here. Now, some pros and cons with this pattern, because not every design pattern is perfect. So I'll go ahead and just list those here. And let's do pros and cons. And the pros is that we have a single responsibility for this actual factory. That is, it's very clear what it's supposed to do. It's supposed to give you a particular type of object from some hierarchy of iGame object. So I do like that. That makes it very clear. It's very easy. You don't have to think too much about how you should properly instantiate some object. In fact, you could have different object types if you have different constructors, and sort of further extend this if you want more power from this particular function. So for example, you might have planes that start off in the air, and one of the attributes might be the X, Y, and Z location that you can change. However, on the con side, that means you do have to make at least 2 updates to the code. Okay, so think about where those are for a moment in our pattern as I expand this. And if you think about it, well, we have to make an update here in our enum class as well as our factory. And this might be accepted. This might be okay. You could keep these in the same file, for example, to make this sort of manageable. But it is something that you do have to consider. Now, the other con is that you may need several factories. So it does add to your code that you need different factories for each of the different hierarchies that you have here, for instance. We probably do want to be consistent with how we're creating objects. And again, that's sort of the point. Now, otherwise, this is pretty easy to update. So it's relatively easy to update and is extensible. Now, it's extensible in the sense that it's easy to just, again, make those two updates, but we are going to improve on this. So maybe I will put actually a question mark if you want to argue with me how extensible it is. I will accept arguments. In fact, there's a pattern known as the extensible factory pattern by Andrei Alexandrescu, which I will show in a future lesson. So in summary, this is the factory method. It's a very common pattern, and it's a very convenient way to consistently create objects. So I personally like the factory method because it's easy to use, it's pretty flexible, and there are alternative or improvements to the factory that can help fit it to your needs. So folks, I hope you enjoyed this video learning about yet another design pattern. And if you have, and if you've been enjoying this series, please go ahead and like and subscribe. It supports the channel and helps encourage me to make more videos like this. So we'll see you in the next one.